Hi everyone, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you, because today we are going to complete the chapter electrochemistry, right? So till now we have discussed electrode potential, we have discussed Nernst equation, all the formulas related to Nernst equation we have done, right? Then we moved, and I have seen that very few students have watched it. Conductance, conductivity, right? Molar conductivity, that is also a very important topic of this particular chapter. And today, students, we are going to do product of electrolysis, right? So this is a topic that students, they hate. Why? Because you have to select, you should know the values to select that what will be the product at anode and cathode. Like for example, they can ask you, you are doing electrolysis for concentrated H2SO4. Now tell what will be formed at cathode and what will be formed at anode, right? You are doing electrolysis of aqueous H2SO4, aqueous NaCl, AgCl, AgNO3. So many different formulas, compounds can be there, right? So in today's lecture, our main focus is going to be on product of electrolysis, and trust me on that, after this class, you will have no worries about product of electrolysis. I'm going to tell you a trick in the end. I'm going to tell you the full detail of product of electrolysis, right? Then the second thing is, we are going to also focus on Faraday's first and second law, based on which they ask the questions, especially from Faraday's first law, right? Then last part is theoretical part, that is batteries, right? So I'll tell you that what all to study from there, right? Okay. Yes, everybody. So are you all ready? Hi, Sriram, Paki, Virat. How are you all? Everybody in the chat box, do let me know if you all are ready for the class or not, so that we can start with the session, right? Very good evening, Asinath. Very good evening. So I hope so your preparation is going really good. And for all my YouTube students, guys, see, in the batch, we know that already a plan has been followed, right? So I was already telling you to get enrolled into the batch, but if you're not able to do so because of some circumstances, then please go through 9-month planner. I have given you how to complete your syllabus. Each week I have given you targets, right, that you need to finish, right? Okay. So I would request you to go and watch that and promise me that you will follow that planner, right? Because 9 months will just fly, right? So you have to be fully focused, fully concentrated. And this time, that's why I'll be taking long lectures right from the next chapter. That is, I'll be starting with DNF block. So it's not like I'll complete DNF block in 4 classes. I'll try to complete it within 2 classes itself, right? For that, I need your attention span as well, right? Okay. Yes, everybody, let's do this. Let's go. So first thing is, to understand electrolysis, first thing that you need to understand is, ma'am, what exactly is electrolysis, right? Okay. So how do you define electrolysis? Okay. So what I'll do here, I'll have a beaker, right? Let's take a beaker here. Here you have a beaker. Now, in electrochemical cell, right, you have two different beakers in which you have anode and cathode. In electrolytic cell, you have only one beaker in which one electrode will be anode and one will be cathode. So I'm just drawing it here, and one will be cathode. Now, if you remember, I told you that for electrochemical cell, you have LOAP. That means loss of electron, oxidation, anode, and anode is a positive electrode, right? But, wait a minute. Yeah, that was for electrochemical cell. That is, anode is a negative electrode, right? But if you talk about LOAP, that is electrolytic cell, where anode is going to be a positive electrode, right? And this is going to be a negative electrode. Now, what all you need to remember here, LOAP, just like SOAP you have, no? Right? Just replace this S with N. That's it. Okay? LOAP, right? Now, if you see this, we are saying this is anode, right? This is anode. And this will be cathode. right? Now, at anode, always oxidation is going to happen. So there is no worries on that. And oxidation is always accompanied by loss of electrons. So I am assuming some, let's say I am talking about copper electrolysis. I am giving you just one example. We are going to study a lot of examples, right? So here if I say that in the solution you have CuSO4 solution, Cu2 positive ion, SO4 2 negative ions, Cu2 positive ions, SO4 2 negative ions. This is what you have in the solution. And this I am saying, whenever you are doing purification of any metal, right, with the help of electrolysis, always and always you will take anode as the impure electrode, right? So anode is the impure electrode of copper, right? It's an impure copper, right? And here you will take a pure copper. Now let's see what is going to happen in both the cases, right? If you see this here, at anode, guys, what will happen, everybody? At anode, there is loss of electron. Everybody in the chat box. At anode, there is loss of electron, ma'am, so no worries. Who will lose the electron? Cu2 positive will lose the electron to get converted to Cu4 positive? No, ma'am. Cu4 positive, Cu3 positive does not exist. So that means simple that copper will lose the electron and become copper 2 positive. Now, in the solution, you will have new copper 2 positive ions. New copper 2 positive ions, right? And 2 electrons that you have here that it has lost are actually moving through this circuit, right? This is connected to positive terminal. This is connected to negative, right? Because this is anode, no? So it will be connected to positive terminal, right? So the electrons are moving here. Electrons are moving here, right? Electrons are moving here. And over here, you have Cu2 positive ions. Now at cathode, we know that there is gain of electrons. So Cu2 positive ions is going to gain 2 electrons and get converted to copper. That means, can I say that here the electrode, right, what is happening to the electrode? It is losing the electron, it is losing the ions. The copper electrode is losing the electrons. Electrons are moving here, losing the ions, it is moving into the solution. So can I say this one thing, that it is getting thinner, right? Can I say this one thing, that it is getting thinner? So how do I write it? How do you write it? Let's try. Okay, let's try. I hope so, right? So it is getting thinner. Wait a minute. It is getting thinner. Yes, almost the same, right? It is getting thinner. And here what is happening? You are having new copper 2 positive ion that are converted into copper. So here you have the formation of electrode. Here you have the formation of electrode, right? Now, can I say one thing, that if you refine the copper, on the refining of copper by using electrolysis method, what is happening here? This impure copper, this particular copper is impure, okay? This particular copper is impure. It is losing the electron, and over here it is also losing some impurities, right? And here you will have impurities that is called anode mud, okay? Here you will have impurities that is called as anode mud, right? And here, when copper 2 positive ions are gaining the electrons, here you have the formation of only pure copper over it. So impure copper is getting converted to pure copper, and here you will see the electrode is slowly and slowly decreasing. The thickness is slowly and slowly decreasing. So that is the overall process of electrolysis, right? Okay, understood? Do you have any problem in here, right? What is the overall process of electrolysis, guys? Let me know in the chat box if you have any problem in the overall process of electrolysis, right? Because now I'm going to change something. What I am going to change? Let's see. Right? Now, I asked you that I am not taking copper solution. I am not taking copper electrode. Let's take aqueous NaCl. Okay? Let's take aqueous NaCl. Now, you tell me what will be formed at anode, what will be formed at cathode, right? For that, you need to understand few points that whenever you have this kind of situation, right, you have aqueous, that means you have water, you have NaCl, right? These two things what you have, right? Now, water and NaCl, these two things you have. Now, what we are going to do, everybody, see this very, very carefully. This is NaCl and this is water, and here what we are going to do, water will have H positive, it will have OH negative. Na will have Na positive, it will have Cl negative. Two problems we are facing. We are going to tell solution for both the problems. First problem is, ma'am, whether the cation will go here, whether the anion will go here. Let's understand that. This is anode, right? This is anode, this is cathode. Now, if you see on anode, always there are loss of electrons, right? So that means here what will happen at anode? So which ion should go towards anode and which ion should go towards cathode? A simple reason is that because anode is positive here and this is negative. So on anode side, always cations you will have. On anode side, always you will have, anions, right? Why? Because anions are negative, anode is positive. So these negative anions will be attracted towards anode, and hence all the anions will move towards anode, right? And if you talk about on cathode side, what you will have? At cathode side, you will have cations, right? At cathode sides, because these are positive and cathode is negative. Understood? On anode side, you will have anions. On cathode side, you will have cations. That is the first thing, right? Now, if I see the similar situation here, right? Now, ma'am, what about the next question? Next question was, if you have aqueous NaCl, you will have H positive, you will have Na positive, you will have OH negative, you will have Cl negative. Now, the choice, product of electrolysis, that's why the name of the topic is product of electrolysis. Which particular anion should you choose that should go here? Which ion should you choose that should go here? Right? That is questionable here, right? Because both are cations, we have two anions, two cations, right? So we need to understand which should go to which side, right? Should we choose OH negative? Should we choose Cl negative for anion? Which anion should you choose? On cathode side, should you choose H positive or should you choose Na positive, right? And only one will be selected here, right? That's why it is called product of electrolysis, which will be formed, right? And what they ask you, this is aqueous NaCl, what you have here, right? According to that, they will ask you the question, okay? So for that, you need to study this electrochemical series to understand what will happen here, right? If you see this here, all these are the values, right? You don't have to learn each of them. I'll give you some important values. Just learn those values, okay? So these are some of the values. And now, based on this electrochemical series, one thing you should know, that which one will be selected here. Which one will be selected? Now, on the anode side, which thing will be selected? On anode side, tell me what happens. On anode side, oxidation happens. So the one which has high oxidation potential, that will be selected. Which has high oxidation potential will be selected. It means which has low reduction potential will be selected. Here, the one which has high reduction potential, because we are reducing it. Reduction is happening. So high reduction potential that wants to get reduced, that will be selected, right? or low oxidation potential, you don't have to write here, right? Okay, understood? Slide is not clear. Wait a minute. Now tell me, is that clear? Right? Now tell me, is that clear? Okay. So, is that clear, guys? On oxidation, you will have high oxidation potential. The one that wants to get oxidized will be there at anode that, yes, I want to get oxidized. I am an anion. All the anions which has high oxidation potential will be at anode side. The cation which has high reduction potential, you will find it on the cathode, right? Okay, so let's understand this with the help of few examples, right? So I'll take one example here. This already I have told you. I'll take one example, concept of water in reduction and oxidation, because water is very important for you, right? So let's understand the concept of water here. The values, guys, definitely you should remember. Okay? Yes, everybody. Yes, everybody. So I'll tell you what are the values that you need to remember. Okay? So on reduction side, I'll tell you reduction potential. On oxidation side, I'll tell you oxidation potential. And I am not going to write the full-fledged reaction, balancing of equations. All that is in redox reactions. It is not here, right? So I'm not going to write that either, right? So if you see water, when it is, let's say, water undergoing reduction, when water is undergoing reduction and when water is undergoing oxidation, right? Now, whenever you will have aqueous solution, you will have both the things. That means reduction means this you will see at cathode and this you will see at anode. Okay. Now, when water is undergoing reduction, it is going to get converted to H2. It will gain the electrons. When it is undergoing oxidation, it will lose the electrons and it will get converted to O2. Right? The reduction potential here, on reduction, I am always going to write reduction potential. Oxidation, I'll write oxidation potential. Right? Reduction potential will be minus 0.83. And here reduction potential is, I think, minus 1.23. Okay. So let me just see this value as well here. Right? I'll just show you that here as well. This is from your NCERT only. Right? So if you see this H2O, wait a minute. Okay. So here you can see, here they have written the reduction potential. Oxygen to water. I am doing opposite. I am doing water to oxygen, right? And here that's why I have written minus 1.23. Okay. So this is the value that we have picked, right? Only the important values I'll ask you to learn, right? This value, and for water also there is, yes. So wait a minute. I think it will be over here. Yes. When water is getting converted to H2, right? So it is minus 0.83. Okay. So this is what you need to learn here in the first group. Tell me, guys, if that is clear or not, right? Okay. If that is clear, then let me know in the chat box, right? Now, this is water. When it is at cathode side, it will be converted to H2. On anode side, it will be converted to O2. Reduction potential when it is converted to H2 is minus 0.83, and oxidation, this is not reduction potential, this is oxidation potential. Oxidation potential is minus 1.23, right? Now, there is one more concept that is called overpotential. And in this concept of overpotential, what you have here, convert H2O to O2, it is very difficult. It is very difficult, right? This particular process is very tough to achieve, right? So that's why you have to provide some external potential. For example, some students, they are so self-disciplined, they want to study, right? Some students, we have to push them to study, that you have to study, we have to do over potential, right? That means we have to apply our own force also, give them planners, everything, so that they can get in the right direction, right? So what we are doing is we are providing over potential. And similarly, water to O2 is a very difficult process. That's why over potential is provided. And if you say this water and this is can be converted to O2, the oxidation potential here is minus 1.23, and over potential is minus 0.23. Okay, minus 0.23. Okay, so it will become minus 1.46, the over potential that you will have here. Okay, let me just check the values also side by side. Yes. Okay, so this is the over potential that you are providing, and hence the overall oxidation potential after applying the over potential, that will become minus 1.23 minus 0.23, and this will be equals to minus 1.46. Okay, so they can individually ask you also that what is the over potential of water when you oxidize the water, right? So it is going to be minus 0.23. Okay, right, everybody? Okay, is that clear? Tell me, is that clear, everybody? See, these things, no, it's very difficult when you do it yourself, right? So that's why I'm saying this particular topic is extremely important for you if you actually want to get into AIMS or get into a good government college. Otherwise, forget about it, right? If you're not even touching these topics, you have no idea about these topics, and you are like okay with that, then that's where the problem lies. Okay, you should not be okay with that, right? Okay, yes, everybody, tell me in the chat box. uh okay, yes, very good, very good. Okay, now let's understand with the help of examples, right, one by one. So I know that first 3-4 examples you will find difficult, but after that you will have that smoothness, right? So this is aqueous NaCl. Firstly, I'm going to write out what is at cathode, right? Then I'm going to write what is at anode. This is where I'm going to write what is at anode, and we will select it. See, if you talk about the ions here, ion is H positive, Na positive, it is water, it is Na positive, and it is Cl negative. Now, water will be written on both the sides. Water will be here also, water, and here also water. On cathode side, water is converted to H2. At anode, water is converted to O2. I am not writing the full-fledged reaction. That is not important for you, right? Now, if I see this here, the electrode potential, reduction potential here is minus 0.83. Here, the oxidation potential is minus 1.46. Okay, understood? Now, if you see this here, this is H2O and this is this. Now, this is Na positive. It is gaining the electron, it will get converted to sodium, right? This is anode where you have Cl negative. It will lose the electron and it will get converted to Cl2, right? This is what we are going to have. Either at cathode you will have sodium or H2, or at anode you will have Cl2 and O2. For that, let's see, when sodium is gaining the electron, let's find it out. When sodium is gaining the electron, what is the electrode potential? When it is gaining the electron, it is minus 2.71. So shall I write it here? Minus 2.71. Write it here. This reduction potential is minus 2.71 or 31, I think 2.71, yes. Okay, now if you see Cl, yes, here you have, right? Here they have told the reduction potential. The oxidation potential will be minus 1.36. Why I'm telling you the values from here? Because possibility is that they can give you the values like on the side page that these are the values. Now tell which will be at anode and cathode. Then the question will be very easy, right? So it will be minus 1.36. You just write it here, right? It is minus 1.36. So this is oxidation potential is minus 1.36. Now tell me which value is bigger. Which value is bigger? Which has more reduction potential? This one, it has more reduction potential, isn't it? This is on the positive side of the number line, right? What about these two? This is on more negative side. This one has more oxidation potential, and that is the reason you will always say in the aqueous sodium chloride at cathode you will have H2 and at anode you will have Cl2. This is the answer. Okay, at cathode you will have the formation of H2 and at anode you will have the formation of Cl2, right? Okay, I am not ignoring anyone, right? Either I can teach or I can, give full attention to you. Okay, yes. Next one is aqueous copper sulfate. Let's understand that. Okay. Next one is aqueous copper sulfate. Let's understand that. Now, aqueous copper sulfate, everybody, if you write the answers in the chat box, I will never ignore you, right? And I can see your charts, okay? So, tell me, aqueous copper sulfate, what are the ions here? Can you see what are the ions here? Aqueous means you have water. Copper means Cu2 positive, sulfate means SO4 2 negative. These are the three ions that you have. Now again I'll do the same thing. One thing is at cathode what is happening, at anode what is happening, right? Now at cathode, Cu2 positive is getting converted to Cu, cations you will have. H2 is getting converted to H2, and here you will have SO4 2 negative is getting converted to S2O8 2 negative, right? And here it is, it's always getting converted to S2O8, right? Just double this number, okay? Then H2 is getting converted to O2, right? Now for copper, it's very, very famous. What is the electrode potential, reduction potential of copper? It's very famous. We have studied this in electrochemistry. We have studied it in other places also. Yes, everybody? Yes, everybody? What is the electrode potential of copper? Reduction potential. It's very famous. Reduction potential is nothing but 0.34. It is positive. It has the positive value. That's why it's so famous. In DNF block, we have seen that, right? Okay, let's talk about reduction potential here, right? So over here, reduction potential is minus 0.83. Here, the oxidation potential will be minus 2.01. And these are the values. See, for sulfur, you should remember because it is very repetitive value. Copper, you know. And these two values, so it is a must to remember, right? Individually also, they can ask you this question. So this is 1.46. Now tell me what you think is having the maximum reduction potential out of these two. Reduction potential is more in this one, right? So can I say this will be choose? Out of these two, which will have more oxidation potential? This will have more oxidation potential. So can I say this I'll choose? So from here, I can say that always and always you will have at cathode, in this case, you will have copper, and at anode, you will have O2. Okay. Tell me if this product of electrolysis is clear to everybody or not. Tell me, student, if this product of electrolysis is clear to all of you or not. Right? Okay. This product of electrolysis is clear, no? Right? Shall I move ahead? Right? Now, I'm coming back to the first page of this particular lecture, that was, and here I have written about if the electrode is inert, and here we have talked about if the electrode is reactive. So two kind of electrodes you have. One is inert electrode that will not participate itself in the reaction. right? And reactive is that will participate in the reaction. I'll show you something here. If you see, tell me, isn't this particular electrode participating in the reaction? So here electrode is reactive. Okay, so the electrodes that are actually of the same solution that is there, if you have the same solution electron, then that will be a reactive electrode, right? So now I'm going to teach you how to have the products of reactive. When you have reactive electrode, then how you will answer the product. Okay, right everybody? Right. So now here you have cathode. This is anode, right? Now, if you see how many things you have. Copper sulfate in copper electrode. This was copper sulfate. Electrode may be platinum, graphite, anything can be there, which is an inert electrode, right? So it doesn't matter. That's why I have written nothing about the electrode, right? Now, because it's a reactor, we already know, I have already told you the whole process here, right? If you remember, this whole process that I told you is of copper only. This whole process, guys, I'll just, okay, this whole process that I have written here is of the same thing. Aqueous, here, do you have aqueous? Aqueous was there, right? Aqueous copper sulfate in copper electrodes, right? Let's understand that, right? Why we have ignored water here? Let's understand that, okay? So add, we have H2O, copper 2 positive, SO4 2 negative. We have copper electrode, okay? Let's do that. Now, when it is gaining the electrons, right? So gaining the electrons is two things can happen. Either copper 2 positive can gain the electron, or water can gain the electron, it can get converted to H2, right? And anode, let's see how many things are possible. At anode, three possibilities are there. Loss of electron can be by copper electrode. Copper electrode, it can lose the electron and get converted to Cu2 positive. Water can lose the electron and get converted to O2. Third is SO4 2 negative can lose the electron and get converted to S2OA2 negative. These are the three possibilities that you have here. Yes, everybody, do let me know if that is clear or not. Yes, everybody, do let me know if that is clear to everyone here or not. Right? So you have total three possibilities here. Wait a minute. Okay. Wait a minute. Sure, we don't have that. It's okay. Sure. Now, if you see this, what is the electrode? What is the reduction potential? Ma'am, it's 0.34. Right? Here we have already, how many times I have written it? Minus 0.83. Ma'am, between this, opposite, this is the reduction, oxidation will be opposite of that, so it will be minus 0.34. Here, oxidation potential will be, we have discussed it, minus 1.46. And here, what was the oxidation potential? Minus 2.01. Right? Let me just verify. Yes, minus 2.01. Okay. So now tell me which will be selected. See, you have all the values in front of you. Now you have to tell which you will select here. What you will select here, you have all the values in front of you now. Now select what you will select, right? So if you see this here, what I'll select, more reduction potential, that means this will be selected. Highest oxidation potential, which is the highest value here, minus 0.34 is the highest value, isn't it? So can I say simply that these two things will be selected here? Can I say this and this will be selected? So here you have copper formation and here you have Cu2 positive formation. And that's why we have done it this way. Here you have at cathode you had copper formation, at anode you have CO2 positive formation. That's the reason we did it this way. Okay. Okay. Yes, everybody. Tell me if that is clear to all of you or not. Right? Okay. So let us do that. Now tell me, are you ready for the next product of electrolysis? If you actually understand this now, it's like a game only. It's interesting, but you just need to understand this, right? So if you see silver nitrate in silver electrode, there are actually two things. One is silver nitrate. Wait a minute. One will be simple silver nitrate solution. If I don't have that, okay. So I'll do this then. Silver nitrate. Okay. Let's do two things here. Okay. So first is silver nitrate without the silver electrode. Okay. Without the silver electrode. Let's do this firstly. Okay, everybody. Now, two things what we have. Anode and cathode. Two things, anode, ma'am, cathode. Right? So, let's write it here. Ma'am, we have two things. One is anode and other is cathode. Right? So, first I'm going to write cathode here. At cathode and this is at anode. Right? Possibilities are aqueous solution you have. So, that's why here what you will have here. Right? I'm just going to write it. Silver will be converted to Ag positive is converted to Ag. In this case, nitrate, NO3 negative is converted to something, right? Let's understand that. Here water is getting converted to H2 and here water is getting converted to O2, right? Okay, so let me just see the value of silver here. The value of silver is 0.8, okay, right? The value of silver reduction potential is 0.8. This value, guys, this too you should definitely know. By now, I think you already can answer this, right? I think it's the fifth time I'm writing this here. 0.83, right? Oxidation potential. Nitrate ion. Can you tell me the oxidation state of nitrogen here? This is x minus 6 is equals to minus 1, x is equals to plus 5. It is in its highest oxidation state. So, if something is in the highest oxidation state, can you oxidize it? No. Oxidation means increasing the oxidation number. If nitrogen is already in plus 5 state, then you can't make it plus 6 or plus 7, not possible. Right? So here that's why nitrate oxidation is not possible only. So only king here is water and here there is no competitor for water. Nitrate is not even eligible. That's why this will be formed at anode. And out of these two, obviously this value is higher. So this will be formed at cathode. Okay, that will be formed at cathode. ठीक है, thank you, gamer. Okay, chalo. Now let's see that. Now, guys, let's see that. So you can say at cathode you have Ag, and at anode you have the formation of O2. Simple, right? Now let's change it. Now what you had here, let's say you have silver electrode also. Let's say you have silver electrode also. Now what you will do? Now here you will also have silver, right? Here you will have silver also. So two things are possible, right? Here you can have one more thing here, that is nitrate. See, it will not have oxidation, that we know, but Ag can lose electron and get converted to Ag positive, which will be oxidation potential is going to be it is 0.8 now, so it will be minus 0.8, right? So that is going to be the oxidation potential here, right? That is going to be the oxidation potential here. Now, can you see everything is changed now? At cathode, yes ma'am, Ag will be formed, but at anode, Now, because of this electrode participation and because this electrode has higher oxidation potential, this is used here. And hence, can you see by just changing the electrodes at cathode, yes, you have silver, but at anode, you will have Ag positive. And this is also called the refining of silver. Okay, refining of silver. Just like we had refining of copper from impure to pure, similarly, it is the electrolytic refining of silver. Right? This we have done already. Right? Two more, and we'll be done with this part. Right? Two more, and we'll be done with this part. Let's understand that. Yes, everybody? Okay. Aqueous sodium sulfate. Aqueous means water. Sodium means Na positive. Sulfate means SO4 negative. At cathode, ma'am, at anode. Right? So, everybody. Last one, let's see how many of you can answer this. At cathode, what you have? C for cathode, C for cation. Still have Na positive. Sodium is getting converted to Na positive, getting converted to sodium. Water will get converted to H2, and that's it. At anode, you will have SO4 negative, which is converted to S2OH negative. Right? Always this is happening. And here water is getting converted to O2. Yes. Now all these values we have already seen. Let me see how many of you are able to answer this. Let me see, guys, how many of you are able to answer this. Yes, everybody. How many of you are able to answer this? Let me see that. Yes, students, I can't see any one of you responding in the chat, right? Okay. Yes. Yes, Yashraj. What to do, Yashraj? You'll just write your NEET exam and say the same thing, right? Say the same thing, right? Okay. At cathode, you have this oxidation. Guys, my throat is already blocked, right? It's literally paining from here. Still, I'm speaking, right? Still, I'm literally putting all my energy here, right? So, all you can do maximum, you can respond in the chat box, right? Okay? That's the maximum amount I expect from you, right? If you can't even do that, then hats off, right? Okay? Yes, everyone. Yes. Good, good. Asinath is the only one who is away, like there in the class. Others are sleeping or what? So let's see this. Here, what you have sodium. It is nothing but reduction potential is minus 2.71. Right here, reduction potential is minus 0.8. Here, oxidation potential is minus 2.01. Here, oxidation potential is minus 1.46. Now, if you see, reduction potential is more in this case. So, this thing will be selected. Here, oxidation potential is more in this case. So, this will be selected. So, can I say in this answer is going to be at cathode, you will have H2. At anode, you will have O2, and that is going to be the answer. Right? This is what most students answer wrong. Right? Okay? Yes, everybody? Let's do last thing here, that is electrolysis of aqueous sulfuric acid. To all the students who are watching this on the recorded version, right? Guys, do comment down your homework, because if you can see, my energy is always high in the class. but the student's energy is so low, it's so like literally it is somewhere hidden, or I don't know, someone has buried it, it's totally dead, right? Someone has killed the energy of the students and it's totally dead, and I have never seen such, you know, dead crowd in my life, literally. Why? Because you guys don't respond only. It's not for me, it's for you. If you're not responding to what I'm asking you, how your brain will work? It's brain exercise. It's not about, okay, ma'am is telling, I'll just simply listen. If you don't ask yourself question, right, then how will your brain start retrieving that? It will be very tough, right? So now aqueous, that is water. Sulfuric acid is H2SO4, which is having H positive, and you have SO4 2 negative, right? Now you have two things. One is at cathode, other is at anode. Anode, right? At cathode, what is happening? You have cations, H positive to H2. At cathode, water is also getting converted to H2. It doesn't matter. First thing is, it doesn't matter from where it is coming, but always it is going to be H2 only. But still, reduction potential or oxidation potential of H positive to H2 is always 0. That is standard hydrogen electrode, right? Okay, very good. Very good. Now, what about the other thing? What about reduction potential here? Let me know. I want to see if you remember this or not, or just lying there, just giving yourself false hope that I have watched the lecture so I remember. No, you have to tell it in the comment section. You have to also answer, right? So that you can have more confidence, right? So at anode, do you have anything else? Yes, we have SO4 2 negative to S2O8 2 negative, right? This I'll write. Here the oxidation potential is minus 0.021. This is minus 1.46. Now just tell me about H2O to H2. What is the answer? H2O to H2. What is the answer? Let's see, Katya, Asinath, let's see if you guys can answer this or not. Let's see. I really hope so you answer right. I really hope so. And I'm waiting for your answers. Yes. Beta, I have not asked you a full paragraph. I have just asked you one question. How much time do you need to answer this? Minus 0.83. How many? Every single line, every single sheet I have written it. Right? Very good, Asina. Very good. So now if you see this here, out of this, obviously this is more. So because of H positive, you will have H2, not because of water. Here you will have, this will win, and here you will have O2. Right? So again, here also, at cathode you have H2 and at anode you have O2. Can you see when you have sulfuric acid, you have the same thing. When you have sodium sulfate, you have the same thing, right? So that is the beauty of product of electrolysis. And this chart I have made for you: NaCl, Na2SO4, H2SO4, CuSO4, CuSO4 in copper electrode, AgNO3 in Ag electrode. So all of these things are written here, right? Okay, so whatsoever is there, all these things are actually your conclusion of what we have studied in last 17 slides. Okay, so in the exam they will ask you one question that you have CuSO4, aqueous CuSO4, what will be formed at anode, right? You have Na2SO4, aqueous and sodium sulfate, what will be formed at cathode? You have NaCl, what will be formed at cathode, right? So these kind of questions is what they can ask you, right? Okay, let's finish and that topic is done, right? So first topic we have already done. Now we are moving towards the second topic, that is Faraday's laws. Okay, Faraday's law. Okay, students, shall we move towards Faraday's law? Two laws of Faraday's we have, right? So Faraday is like, I'm everywhere. So like physics is also like filled with Faraday's law. Now he was like, also I want to someone who wants to take part in every single thing, dancing, singing, everything, right? So Faraday is that person, right? He's like, okay. So let's understand chemistry, right? So you're talking about electrolysis, you're talking about current, that is related to physics only. So he said that basically what you're doing, right? You are converting, you are passing the electrical energy, you are converting that into a chemical reaction, that is electrolysis, right? Electrolysis is you pass electricity and a chemical reaction will be generated out of it, right? That's why you have already this battery linked here. Battery is already here, right? Battery is here, you are converting this electrical energy to produce some chemical reactions. So what he said, that because you are passing the electricity, right? You're passing on the electricity, then something is deposited on cathode or anode. Then this particular deposition depends upon the current that you pass. Okay? Depends upon the charge that you pass. Okay? Understood? So what he told, so first thing is Faraday published the results during this in the form of following well-known Faraday's two law of electrolysis. First law is that amount of chemical reaction which occurs at any electrode, cathode and anode during electrolysis by a current is proportional to the quantity of electricity passed through electrolytic cell, right? That means he said that the weight that is deposited is directly proportional to the charge. Now, charge is nothing but it is current into time. It is I into T, right? And when you erase the proportionality sign, it is ZIT, right? So you can also write it as ZIT. Now, what is this Z? Anybody in the chat box? This Z is, what is this Z? This is called electrochemical equivalent. Okay, electrochemical equivalent. Equivalent. Right? So this is equals to molar mass by NF, and this is IT. This is the full-fledged formula that you have. Right? This is the full-fledged formula that you have here, that this is equals to molar mass, or you can say it was actually equal to equivalent weight by Faraday, but equivalent weight is equals to molar weight by N factor. So it is directly we have written it as weight is equals to molar mass into current into time divided by N factor into Faraday. Okay? Yes, everybody? Is that clear? Is that clear? Right? So that was the first law of electrolysis, and based on this, so many questions you will see here, right? So what is exactly Faraday? That is nothing but one Faraday is electricity produced by charge of 1 mole of electron. This also you should know, that if you talk about 1 mole of electron, how much charge it carries, that is 1 Faraday, and that is equals to 96500 coulombs approximately, right? So for approximate calculation, we use 96500 per mole. That means for 1 mole, this is the charge carried by the electrons, right? Okay. Okay. Okay, Sai, great. Okay. Okay, so let's do the next part, right? Okay, the amount of charge in Faraday required to obtain 1 mole of iron in Fe3O4 amount of charge they're asking you. In Faraday, you have to tell required to obtain 1 mole of iron from Fe3O4. So if you see this, required to obtain 1 mole of iron from Fe3O4. Iron is you need to obtain, right? So if I say this will be 1 by 3, can you just tell me what is the n factor here? N factor here will be 3x minus 8 is equals to 0. So x will be 8 by 3. So can I say this will be positive 8 by 3 and this is 0. And this is 0. So the difference here is 3. And for one iron, see, here this is for 1 iron, that is positive 8 by 3. For 1 iron, right, this also should be 1 by 3. So I just divided this by 1 by 3. Right, I have just divided it by 1 by 3. Now, once you have this, you have to apply the unitary method here. I'll just tell you how to apply unitary method. Right, x you have calculated. Now, simple unitary method here is that this is the charge required, right, to convert, plus means this is the n factor, and you have 1 Faraday. You want to calculate for 1 mole, right? So you'll just simply do the number of what is the charge change, that is the n factor, multiplied by Faradays. That will give you the answer, right? Now, over here, if you see, this is 8-3. Basically, it is 8 by 3 Faraday, right? But 8 by 3 Faraday is for if you have Fe3O4 and this is for 3 iron. But when you talk about, you can say, the simple thing you can say that for 3 iron atoms, 3 mole, you can say 3 mole of iron atoms. Here it is 8 by 3 Faraday. Okay. So for 1 mole, it will be 8 by 3 multiplied by 3 Faraday. So answer will be 8 Faraday. Okay. Yes, everybody? Clear? Sure. Now, let's do the next thing. Right, wait a minute. Acha. They have asked you amount of charge in Faraday required to obtain 1 mole of iron from Fe3. Wait a minute. Here, so we have already taken 1 mole. No. Then it will not be like this. Because here they have not actually balanced it. Right? If you see, if you do the balancing of this equation, which is there in redox reactions, right? So once you do the balancing of this reaction, if you see, 8 electrons are required for 3 iron. So for 1 iron, it is 8 by 3 electrons only. So for 1 mole, it will be 8 by 3 Faraday. Yes, so it is 8 by 3 Faraday exactly. It is not approximately, it is exactly 8 by 3 Faraday. And this particular thing you will learn from redox reactions, okay? This balancing you will learn from redox reactions. I'll teach you that. I think maybe after periodic classification, I'm going to pick redox reactions. This balancing is there in redox reactions. Very simple method are there. Now, once you know how to balance, then you can just simply say for 3 iron, you have 8 electrons is gained. For 1 iron, 8 by 3 will be gained. So that means for 3 iron, you have 8 electrons. For 1 iron, you will have 8 by 3 electrons. For 1 mole of iron, you will have 8 by 3 Faraday, because 1 mole of electron is nothing but it is Faraday. Okay, right? So that's how you can answer this. Now let's do the second law. But before second law, let's understand some more questions here. Right? Let's understand this question here. So this will do. Wait a minute. Let's just show you some questions. So here you have, this question states that a current of this much ampere, this is basically based on Faraday's first law, right? A current of this much ampere flowing through 10 minute deposits this much of metal, the equivalent weight will be what, right? So this is exactly, the first question that I taught you is not exactly based on first Faraday law. It is a general question, okay? but this is based on Faraday's law. A current given to you flowing for 10 minutes, time is given, current is given, weight is given, equivalent weight. So weight is equals to equivalent weight by Faraday multiplied by IT. So equivalent weight is equals to weight into Faraday into I into T. Weight is nothing but 3 grams. Faraday is 96500 and this current is what? 9.65, right? Okay. What I'm doing? WF, this should be IT. You are thinking that what I'm doing, right? Weight is 3, Faraday is 96500, current is 9.65, and here this is 10 minutes, so in seconds it will be 10 into 60, right? So this will cancel. Here this will be multiplied by 100, this will cancel, and this will be multiplied by 2, so it will be 100 by 2, that is nothing but 50. So answer is going to be C is the correct answer here, right? Very good, Sai, very good, very good. So very good, right? So it will be 50, right? So it is a simple thing that is based on your Faraday's first law. So W is equals to ZIT, it is equals to E by Faraday IT, it is equals to M by NF IT. This is what you need to remember, right? That's it. That is also done. Let's see some other question here. That is, let's see. See, I have also picked up some JEE means questions here. This is the JEE means previous year question, because in JEE means the questions are repeated in NEET, right? So that's why I have picked up this question. Okay. So electrolysis of 600 milliliter aqueous solution of NaCl for 5 minutes, changing the, it's a good level of question. Okay, changes the pH of the solution to 12. The current in ampere used for given electrolysis is what, right? Okay. Electrolysis volume is given to you, right? Of NaCl for 5 minutes, time is given to you, pH of the solution is given to you, right? Okay. Now, can you calculate the number of moles here? Can you do that? Yes, you can calculate the number of moles. Okay. So let's understand this thing with the help of number of moles. Don't we have some extra page here? Yes, we have this extra page. What I'll do? Okay, let's understand this with the help of one important thing here, that is in terms of number of moles, how you can write this formula. Okay, weight is equals to molar mass by N factor Faraday current IT. Okay, so this will be weight by molar mass IT by NF. So can you see weight by molar mass is nothing but it is number of moles. So can I just write, just do one thing. This is N factor, this is F. Okay, this is N factor, valency factor, and this is number of moles. This is number of moles. So I'll just write N is equals to IT, NF, and this is. So if you see this thing, current they are asking, if you see this, moles is equal to IT by N factor into Faraday. Can I see one thing here, that this is a very interesting question. This has been asked in just, I think, 2024 or 25 in JEE. Exactly same can be repeated for your NEET. Same ditto copy paste can happen in your NEET 2026, right? So this is mole, right? You can calculate mode. I'll tell you how. This is what they are asking you. Current is what they are asking you. Time is given to you. Faraday, you know. N factor also you can calculate. Okay. So how you will calculate the moles? I'll simply give you the answer here. Moles is nothing. Tell me one thing. This is given to you. pH is given to you. pH means nothing, means H positive ion concentration is 10 raised to power minus 12. Okay. Now, if I write this here, volume is given to be 600 milliliters, right? So, can I say that molarity is equals to number of moles divided by volume in milliliter, then it will be multiplied by 1000. Okay. So number of moles will be molarity into volume in milliliter divided by 1000. Okay. Molarity is nothing but it is 10 raised power minus 12 because that is the concentration. Volume is given to be 600 in milliliters and this will be 1000 here. And when you divide it, it will be number of moles will be 6 into 10 raised power minus 30. Is it? These are the number of moles. So can I just put these moles here? All I need to do is I just put these moles here, right? Let me just put these moles here. What is the N factor? You know, for N factor, again, redox reaction will be useful for you. They are saying electrolysis of aqueous NaCl. If you remember in NaCl, you have water also. You had NaOH, right? Then H2 was formed here and Cl2 was formed here. Do you remember aqueous NaCl? Right? So here N factor is going to be 1. Right? So directly you will put the value of N factor. Current is nothing but it is number of moles into N factor into Faraday divided by time. That's it. Number of moles you have calculated already, right? If you see, wait a minute, yes. Wait a minute. What they have given? They have given you pH, na? Then so we don't need to do this, right? Wait a minute. Here what they have done. This you don't need to do this way, okay? Just put the value of N factor here. This they have put the value of time here. 5 minutes they have converted to seconds. This is Faraday. This is number of moles if you remember, right? And this is actually number of moles and N factor is 1. Let me see why my N factor is coming out to be different. Wait a minute. Wait a minute. Why my number of moles are coming out to be different? Electrolysis of this, the solution of NaCl, the pH of the solution is 12. pH of the solution is 12. So H positive is 10 raised to power minus 12, right? That is the molarity. Yeah. See, one thing you should remember here. What is that one thing? Right? That we are going to look for the concentration of OH negative ions. Why? Because if you see in this solution, you will not have H positive, you will have OH negative ions here. This is what you need to look for, right? So that's why here was the mistake. Wait a minute, because here in the answer you have OH negative ions. So the concentration, molarity you should also put for OH negative only. If H positive is this, then OH negative will be 10 raised to power minus 2. So here you should put 10 raised to power minus 2. Okay. This should be 10 raised to power minus 2. This should be 10 raised to power minus 3. Okay. This should be 10 raised to power minus 3. Okay. This is a very important question, guys. This is a very, very important question. Okay. Now everything is same. Current is equals to 6 into 10 raised to power minus 3 into 1 into 96500 divided by 5 into 60 because they have given you 5 minutes. Okay. Yes, students, do let me know if that is clear to all of you or not. Yes, students, do let me know if that is clear to all of you or not. Next question here. Amount of electricity in coulombs required for oxidation of 1 mole of H2O to O2. Right? Electricity for oxidation of 1 mole of H2O that is converted to O2. Oxidation is happening. Amount of electricity is what they are asking you in coulombs, right? And this should be 1 mole, right? Now, if you see this here, if this is 1 mole, this will be half and this will be H2, right? Now, if you see this here, or you can just ignore this, this is the thing that you will have for 1 mole. First, you need to find the N factor here for 1 mole, right? You need to balance this equation, how many electrons are gained or lost, right? then that will be your N factor multiplied by Faraday, right? So simple thing is, this is the balanced chemical equation that you have, right? In this case, for 2 moles of H2O, you have 4 electrons. That is, 4 is the N factor here, right? So if I say you are taking 1 mole, then 2 electrons will be lost, right? Now, do you remember this equation that we have weight by molar mass is equals to IT by N factor into Faraday, right? So number of moles into N factor is equals to IT by Faraday. That is nothing but charge by Faraday. Faraday also you know. Now I can see from this equation that if number of moles they are defining for 1 mole, and this they are defining for 1 mole. So for 2 moles you have 4 electrons, for 1 mole you will have 2 electrons. This charge you have to calculate, this is given to be 96500. So easily you can answer this, just put all the values and you will get your answer. Okay, just put down all the values and you will get your answer, right? You can solve it. This is the traditional way of solving it, or you can simply apply this method, that is the in fact that is simply, you can say that for 2 moles you have 4 electrons. You can say for 2 moles you have 4 electrons. 4 electrons means 4 Faraday. For 1 mole you will have 2 Faraday. Simple answer, right? So answer will be 2 Faraday. Okay, Faraday value then you have to put and you will get your answer. Or if you want to answer it with the help of the equation of Faraday's first law, you can use this particular method. See, if you want to know the core method, that is, this is the actual method, this is the direct method. For 2 moles you have 4 mole of electron, that means 4 Faraday. For 1 mole it is 2 Faraday. Faraday value is 96500, and hence you will have your answer, right? Okay, done everybody? Clear? Now before going to batteries, let's understand the Faraday's second law. Where is Faraday's second law? Where is that? Yes, here it is. So in Faraday's second law, they are saying that, let's say you have 1, 2, 3, they are connected in series. Okay, they are connected in series. Now, if they are connected in series, that means same current is passing through them. Now, let's say they are saying this is A, this is B, and this is C. Okay, this is A, this is B, and this is C. Then this is a weight deposited on A, this is the weight deposited on B, this is the weight deposited on C. Then what you can say here, let's say this is the equivalent weight of A, this is equivalent weight of B, this is equivalent weight of C. Then according to Faraday's second law, the ratio of weight by equivalent weight of each of them will be equal to each other. The ratio of weight and equivalent weight will be equal to each other. This is Faraday's second law. Is that clear, guys? That is called Faraday's second law. Is that clear to everybody or not? Right? Yes. Now, there is no as such question that I have written here. So, but I'll do one thing, right? Just to make you understand this thing more clearly. For example, let's say you have 2 things, right? What are these 2 things? Let's say you have silver, you have 2 salts, right? Let's say here you have AlCl3 and here you have AgCl. Or you can say AlCl3, you can see here you have anything you can write. Let's say you have NaCl. Okay, right? So here, for example, they have given the weight of Al deposited is X gram. The weight of sodium deposited, you have to tell. How much amount of sodium will be deposited here? This is what they are asking you, right? So simple thing is, you will say that weight of AlCl3 Al deposited by equivalent weight of Al is equals to weight of Na by equivalent weight of Na, right? So what you have to write here, weight of Al divided by, this is nothing but, if you see this here, this is existing in Al3 positive. This is existing in Na positive. So here n factor is 3, here n factor is 1. Okay? Because 3 electrons it is losing 1 electron. So it will be molar weight of Al multiplied by 3. This is weight of sodium. This is molar weight of sodium multiplied by 1. Now guys, if they have given Al to be x, this is x, 3x divided by molar weight of aluminium. This is the weight of sodium is molar weight of sodium divided by 1. And that is going to be your answer. Put in the molar weights of sodium and aluminium here and you will get your answer. Okay, that's how you apply for simple second law. Just equate these two things. If they have said that this is connected in series, and automatically you will have your answer. Okay, right, students? Okay, right. Let's get on to batteries. And batteries, now there is nothing to teach you here. Most of the things are cramming based. I'll not teach you about batteries, right? PDF will be provided to you. All you have to do is go through that. See, there is no benefit, right? So I'll tell you that what are different types of batteries, right? But best part is if you start writing on your own the batteries, right? Because it's about learning which is formed at anode and what is formed at cathode, right? So here if you see, if you talk about when galvanic cells are connected in series to obtain very high voltage, then they are making a battery. Like batteries, we use it at our home also. You have battery in this watch, I have battery, right? On the cell phone, you have battery, right? So everything around us, your inverter that is charging, getting charged by battery, your laptop, it has battery, right? So all these things have batteries. So we are going to talk about those batteries only. So basically batteries are of two types. One is primary, one is secondary. If you talk about the primary batteries, right? Primary batteries can be used for so long the active materials are present. Once they get consumed, the cell will stop functionally. Now tell me one thing. Your phone's battery is low. Will you just throw your phone or your phone's battery and purchase a new one? No, right? We don't do that, right? But if your watch battery, it is dead, what you will do? You will replace it with a new battery, right? And it's very cheap also. Now, these primary batteries are the batteries that you have in the watches. In this mic also we have the same battery, right? This mic is actually rechargeable. Here we don't have the same battery. This is actually rechargeable. So here you have, in this mic we have secondary battery. So there's one old mic that I used to have that is connected by wires. So this is a wireless mic, right? So that was connected by wires. So that wired mic that I used to use before, right? Why I discarded that? Because the battery used to get low every often, like every month. So I had to replace it. No doubt the battery cost only 5 rupees, but you know, sometimes you don't know that in the class, in between the class, the battery will go, right? So you have to be very attentive. So that's why for me, this is best, right? So similarly, we use things in our phone battery, right? Now, that is the reason we are talking about these two types of batteries. One is primary and one is secondary, right? So primary battery is not rechargeable. Like you have Leclanche cell, right? This is not rechargeable. So in Leclanche cell, you need to understand what is anode, right? This is the reaction where zinc lose the electrons. At cathode, what you have is manganese oxide, you have ammonium ion, it gains the electron, right? So what will happen? You will have graphite rod surrounded by powered magnesium dioxide, and this is your cathode. Now, electrolyte, a moist paste of ammonium chloride, it is used as the electrolyte. So these all are cramming based things, guys. That's why I have just written it here. You have to do it yourself. All I can tell you is applications here. You can see the cell potential is very low. That's why these are used in our uh, earphone machines, right? So earphone machines, I'm saying in hearing aids, right? It is used, right? Because we can't have that much high voltage connected to our body, we can't have that, right? So that's why cell potential is very, very low here. Used in transistor clocks, right? Then next is mercury cell is the same primary cell. This is anode, zinc amalgam you have. Then here, mercuric oxide you have, mercury is formed. This is the electrolyte here, where it is used in hearing aids, watches, low current devices. It is very low. It is 1.35, right? Remains constant during its life as ions are not involved, right? So if you can see here, ions are not involved in this case. That is the reason it will remain same, right? It will remain same. Then there is secondary batteries. In secondary batteries, like you have your phone battery, right? Inverter battery. These are secondary batteries, right? Which we can recharge, right? So secondary cells which can be recharged again and again for multiple uses. For example, lead storage battery, nickel cadmium battery. Very, very important, right? So lead storage battery, what you have here, anode reaction, cathode reaction, go through this. What is the electrolyte? Very, very important. As it is, you should know what is happening here at cathode and anode, right? Then, where it is used, automobiles, inverters, big battery, it is having very high potential, right? On charging the battery, reaction is the reverse. This is a very, very important point. That on charging, when you are charging the battery, this reaction will get reversed. Okay? Next, nickel cadmium cell. So again, right, overall reaction you should know, right? And in this particular cell, if you see, there is a jelly like placement. Okay, in this particular, these are like, you have pages of pages of books, right? Similar way it is placed here, right? Roll arrangement separated by layered soaked in moist NaOH and KOH. Long life than lead storage cell, but more expensive to manufacture, right? Okay. Now, last is fuel cell, right? And fuel cell is very, very economical. It is environment friendly. So what we do here, this is very important. We say all the batteries are important. Lead storage, nickel, cadmium, and fuel cells are most important, right? So galvanic cells that are designed to convert energy of combustion of fuels. When there is combustion, that energy is converted to something into electrical energy, that is called fuel cell. And here we are going to talk about fuel cell, where we are going to use hydrogen and oxygen to produce water, right? In this cell, hydrogen and oxygen are bubbled through porous carbon electrodes into concentrated aqueous sodium hydroxide solution. Over here, H2 and O2 are bubbled here, and this is sodium hydroxide electrolyte over here. Catalysts like platinum or palladium. Wait a minute, guys. Yeah, you have to memorize. You have to memorize, right? You still have time. It's not like you have the exam on the next day. So you have time to memorize. Just do practice, okay? Start writing it on your own. That's why I'm saying it's more of, there is nothing that I can teach you here. It's not an understanding perspective, right? It's more of cramming thing, right? So what is that anode? What is that cathode, right? So that's why I'm rushing it, right? So the cell runs continuously. So as long as reactants are supplied, it will run, and here you have electrode is carbon with finely divided platinum for increasing electrode potential. This is electrolyte, and here you have the reactions. Reactions are very important. At cathode, you have OH negative. At anode, you have the formation of water. Very important. Reactions are very, very important. Overall, is this reaction that you have seen multiple times in chemistry, right? Okay. Then a use of this cell is that in space, right, where they don't have groundwater, they can't take out groundwater at space. and how much storage, how much water they can take, right? So that's why what happens exactly in the astronauts, what they do, the cell was used for providing electrical power in the Apollo space program, right? From this electricity is generated. The water vapors produced during the reaction were condensed and added to drinking water supply for the astronauts, right? So they used to use it for the drinking water. Okay, right? नहीं, this is actually not there. Okay, chal. I think that's it for today, guys. That's it. That's it. And this is the first question, and we have completed the chapter. This is your homework. Let storage batteries discharge. What is the correct answer? Then you have this is the second question. Okay. Okay, and guys, understand? Yes, everybody. Yeah, how will the question come? They can ask you at anode what is the reaction, at anode what is formed at lead storage battery, at cathode what is formed, what is the electrolyte that you have used, right? Or directly they can give you a question and they can mark something blank and they can ask you what is this, right? So that's why direct, it's not like some ghuma firage they will ask you some question, direct questions they will ask from here, right? Okay, chal. Okay then guys, that's it for today. And guys, let me just tell you before going that this is our Vedantu's DNA batch that you can see where all of us are teaching right now. The classes are going regular, right? And you can see this is right now available at 4,999, out of which, right, you will have 300 plus live classes, right? And you know, not only the live classes, right, you will also have mock tests, you will have test series, you will have quizzes, you will have leaderboards in the class, right? So everything, so that you can understand your competitive level, that how much you need to improve, and you still have 9 months, right? So I would really advise you to get enrolled into the DNA batch so that your NEET 2026 preparation should be top notch, right? We provide you modules, series, mock tests, everything that you need is over there in this batch, right? Okay, just click on this view plans. So whatever plan you want to select, whatever I mentioned will be provided at 4,999, that is a prime batch. If you want to get this NEET quick revision cards, you want to get the test series hard copy, then this is the batch for you. If you want to get Tattva modules in hard copy, here also it is provided, but here it is provided in the hard copy version. If you want to get it in the hard copy version, that is provided at 10,999. Okay, right? So guys, that's it for today, and I'll see you all tomorrow in the next class. Till then, bye-bye. Take care. See you all in the next class. Bye-bye. Bye, students. Bye-bye. Thank you so much, Sai, Asina. See you all in the next class. Bye then. Don't forget to do your homework. Bye-bye.